Hello guys and welcome back to the channel. Today I'm going to show you how to create another group node that will enable you to array objects just like the array modifier. Probably at some point we will get the array node out of the box, but for now we need to do something like this. And as usual, you can download this array group and purchase it for just $2 from the link in the description. It's a way to support this channel, but if you don't want to do that, you can just watch me how to recreate this array node yourselves. So let's begin right away by showing you how it works. So here we have a simple cube, and we have a geometry nodes modifier enabled here with nothing but the group input and the group output nodes, and we're gonna insert this array modifier in between. So our geometry passes through and it gets out from this geometry output here. And so look at these parameters that we have. We have three for now. Maybe I'm gonna update it in the future, but for now we have these three modes of this array node. We have the constant, it's the constant offset, the relative offset, and the radial offset. We have the count of the arrays, so how many copies, and the other parameters that I'm going to explain in just a second. So let's start with the constant offset, which is 1. Relative offset is like here, but anyway, constant is 1 and the count is 10. So let me just hide this one for a second. And so where are the copies? Well, we don't have our distance set up. We just have 0, so we need to add something here, and here it goes. So you can array it just like the array modifier on the X, Y, and Z axes, and you can add as much copies as you like, as you can see. So this is the constant offset, and so we actually set the dimension of the next copy and the next copy and so on. But if we have a relative offset, then it's even simpler. It just takes the dimension of our original object and it arrays it depending on its size. So if we set it to 1, it's going to be, as you can see, if we set this to 0, then it's going to be like a stack on the z-axis. And okay, and then we have the radial offset, and this one is a bit more complicated, but it's still quite simple. First, to be able to radially offset something, we need to have a center of rotation, and so we're going to use an empty in this case, but you can use whatever object you want that's in your scene just by selecting it here. So I selected this empty, but I could have used whichever object was in my scene. So this is the center of rotation, and then we can set our angle and the number of copies here. Okay, so the angle here is the angle of the first copy, and so the next is going to be this angle times 2, and so on and so on. And then another couple of things we've got here are realize instances and merge option. So realize instances is okay, let's show you this with the relative offset with just these z value stacks. And in this case, if we realize the instances, then well, you know, the realize instances of the geometry nodes, these are not instances, but it becomes geometry. And anyway, and if we have the merge option, then it's going to merge the vertices that are practically in the same position here. And that's it. That's practically how this array node group works. And now I'm going to show you how to recreate it. And I'm going to show you how it's constructed. So let's begin from the start. Okay, so we need to create a line that's going to instance our objects on. So this is practically the line. As you can see it here, I'm using the Shift Alt click, which is the shortcut in the node wrangler that connects the output, so you can see what comes exactly out of this node. So let's just add some of this so it's not empty. Okay, so we got a constant. Okay, now, so let's see our mesh line. This is our mesh line. And how do we construct this mesh line? We just use these X, Y, and Z parameters that we set. If we set them all to 1, sorry, our mesh line is going to be like that. Since this is the mesh line that we chose to have our start location 0.0, as you can see, this is the origin point, so the first point is 0, 0, 0, and then we offset each next vertex this exact amount, so 1, 1, 1, 1. If we have it like only on the x-axis, so this is 0, is going to be parallel to the x-axis. And so this is how we add points on this mesh line, just by changing the count. So count 2, we have the first vertex, and then the next one is offset by this distance, 1, 0, 0. And then if we want more objects or more vertices, in this case, we will be adding 0, 0, 1 vertex on and so on. Okay, so this is the constant offset. And how do we do this constant offset to change it when we want it? So we connect our constant relative radial value, which is 1, 2, or 3, and then we just pass it through the less than. This is a math node with less than operation, less than 2. So when it's 1, it's going to come out true, and when it's 2 or 3, it's going to come out false. So when it's 1, we need the true, so we're going to plug in this node, which is the mesh line that instances our geometry. So our geometry comes out here, and then it gets instanced on points of this mesh line, and so we get these objects on each vertex, sorry. Okay, like this, so you can see it better. And that's if we have 1 as a constant relative radial option. But if we have 2 or 3, then outside of here it comes just our geometry, because when it's false, so when it's 2 or 3, when it's false, it comes out only this geometry, and then doesn't get instanced, but it just gets sent on. Okay, so now here we have or our geometry, just our original geometry, or already our instance, and depending on 1, 2, or 3. And then we go ahead, let's just set it to 2 now. So if it's 2, then we have our relative offset, and it works the same way. But here, let's go and see what we got here. So our geometry comes out here and gets instanced on another mesh line, but this time our mesh line needs to have a different set of parameters. It's still an offset, but this time our offset needs to be exactly the size of our object. And so how can we know the size of our object? We have, well, I have like a node group that I will show you. It's pretty simple. It just goes in as geometry, and it comes out with the size of X, Y, and Z. And what happens in this node group, I'm going to show you. It's very simple. So we have our group input geometry in, and then the attribute statistics that gets what attribute? The attribute of position, X, Y, and Z. And then this statistic, for example, this X value of all geometry inside my geometry, the maximum X coordinate and the minimum X coordinate gets subtracted, and so you get the size. And we do that for all three coordinates, so y and z. So this is how you get the size of your geometry, and this is what comes out. So so I need to multiply this, my size. So if my cube is 1 by 1 by 1, this size is going to be 1 1 1. If my cube is 2 by 1 by 1, it's going to be 2 1 1. And that's what we need to multiply to the x, y, and z factor here. That's going to determine our offset size. Get it? Okay. And again, count is here. So mesh line, offset, or the vertices are placed here based on also the count. If we up the count, it's going to go bigger, so on. And then we instance the geometry here. And then again, of course, our switch, constant relative radial. This one is a little bit more complicated, but not that much. It needs to have, when it's 2, it's true, and when it's 1 and 3, it's false. So we need to, well, we could have, yeah, that was easier. I'm going to do it as you're here. We're going to just change this to equal. Okay, equal to 2. Otherwise, it's false. It's the same thing. So we can just delete this. Okay, when it's equal to 2, it's going to look at what comes here in true. And when it's not 2, it's going to be false. So it works quite well. Okay, see. And this is the switch. So if it's 3, then here only the geometry gets passed because it's not 1. If it's 3, also here only the geometry gets passed and goes on. Okay, and then we have the radial. So the radial, it's always simple as the other ones. So here we have greater than 2. So if it's 3, it's true. If it's less than 3, if it's 2 or 1, it's false. And we need to connect this instance on points. But here we need to have an arc instead of a mesh line to instance our objects on. So we're going to use our arc. This is our arc. We don't see it because we don't have an angle. So we just need to up the angle here. Maybe it's like this. And the count, okay, is 11 and it's 3. Okay, so what's the arc? This one is a bit more complicated, but not that much. So first, we need to have an object info node that we're going to connect to the rotation center object, which is our empty in this case. So we connect our object and we need to take the location of our object. So if you move your empty, you can see that the arc changes because, of course, it depends on its location. Okay, so now in this arc, we need to set the radius. And the radius is obviously, since here is our object, our cube, it's the distance between the empty and our object. So it's quite simple. We just need to distant. We have okay, this is another node group that I use, and it's quite simple. It's just you get 2 vertices, 2 coordinates of the vertices, and it returns the distance between those 2 vertices. It's very simple. It's just plain geometry math, and you can see that it's nothing really that complicated. Pythagorean form, and that's practically it. And this is our radius, and then we need to determine the start angle. This is a bit more complicated because the start angle depends on the position of your object in respect of your empty. So my object is here. I know you cannot see it right now. That's because I'm looking at the, but it's, as you can see it, it's here. If we can count 0, so this is our object. So my arc needs to start right here, even though it's now, have you seen it like this? So it needs to start here, and it generally, an arc starts at the vertex 1, 0, 0. So it would start here, respectful of the empty. But we need to find this angle. So this angle is what we're looking for. I called it beta, but okay. So this is the angle we're looking for, and how we're going to get it. Let's go back here. So the angle is this angle again. This angle. So how are we going to get it? We will need a little bit more of math. So we need to location of this. So we need a vector from 2 points. This is another node that I created, but it's not that complicated. It's just geometry and a bit of math. So if you have 2 positions, this is how you find a vector between these 2 vertices. And then we have the angle between 2 vectors, which is the same thing. And just a bit of math. Let me zoom in so you can check it out. This is how you find an angle between 2 vectors. So we need to find the vector between the empty and the 0, 0. So this is the 0, 0, and this is the empty. So this is the vector that we'll find with this node. And then we need to find the angle between this vector and the 1, 0, 0 vector, which is this one, right? And so it will return the angle. Then and then that's the angle that we want. But when we have a negative y value, so if this one here was on the negative y, then our vectors would be reversed, and then they would come out as negative. So when our y is negative, then we need to multiply it by -1 to get the right angle, because otherwise we will get the inverse angle, which is this one. So sorry, not this one, but this one. So so practically that's why we have this switch here, that when y is negative it comes out with this, and when it's positive it comes out with this, or the other way around, but you got it. And then we have the start angle, and then we just need to know how big our angle needs to be, or our arc needs to be, by multiplying obviously the angle that we want our first copy to be by the count subtracted by 1, because the first copy doesn't count as it's in 0. And that is practically it. So it comes out, looking like this if we want the radial offset. That's what we did here, remember. Okay, and then the last 2 things are not that complicated. We have just the realized instances switch. If it's true, it passes through the realized instance node. If it's false, it doesn't. And then again, the merge option, I already I repeated the realized instance, so it doesn't depend on this node. So it doesn't depend on realized instance. There's nothing to merge if the instances aren't realized. So this is how you do that. Anyway, guys, so this is it. Remember, you can download this array node from the link in the description for just $2. And I will see you in the next one. Bye bye.